Hello everyone, today we will be examining the contents of this switching power supply, just so that we can reverse engineer how a typical switching power supply works, and just have some fun along the way. So this is just a proprietary power supply for a speaker that I actually did a video on, and it has a permanently attached cable with a miniature barrel jack on the end, as you can see, quite a bit smaller than a regular barrel jack. So without further ado, let's crack this thing open. Switching power supplies tend to be hard to open, and this one seems like it's no exception, because it almost seems like it's welded or something. Let's see if I can, well, we can get rid of this cable here. And, let's see if I can prise open this, whatever this thing is. Okay, this will definitely take some time. Let's see if I can cut through the side of it, cut a corner. No, I think this one will take some time. Okay, I finally got the thing open. Let's see if I can do anything about this. Oh no, the pins are soldered. That's gonna be annoying. So while the soldering iron heats up, let's just mark some of the features over here. We have the transformer. Looks like we have some primary smoothing capacitors, a fusible resistor, 4 discrete diodes that form a full bridge rectifier, and I think I see an interference suppression capacitor back there somewhere. Main control chip, an optocoupler, some sort of auxiliary capacitor. Then on the secondary side we have what I assume is probably a voltage reference, maybe, and then a pair of secondary smoothing capacitors, a gigantic diode, and a smaller inductor. So hopefully the soldering iron is now up and running, and we can get some of the stuff out. Actually, you know what? Maybe I can just pry down here to get this board out, and then sheet these up. Let's wait. Okay, so I finally got the board out of the thing, and so let's just, I didn't actually desolder it, I just bent it enough to cause metal fatigue in the pins, so now it's completely out. So, this is a typical flyback switching power supply, which is very common for small wall warts and stuff. This one, I do not see any sort of discrete high voltage transistor. The only thing that looks a bit like a transistor is, you probably can't see it, but there's a little doodad that looks a bit like a transistor. This thing, which is probably a voltage reference, I said that before. A lot of this stuff is covered in what appears to be hot glue, so that's kind of annoying. But anyway, let's see. Let's examine this for any sort of safety failures. The transformer, it's directly mounted on the board. I do not see any sort of triple insulated secondary, and the isolation distance is pretty good. That's perfectly acceptable, especially for 120 volt mains. And I see a small blue capacitor down in there. You probably can't see it, but I can. And that could be an interference suppression capacitor, in which case that would not be rated for the kind of voltage that an interference suppression capacitor should be able to handle, unless there is some sort of interference suppression inside this transformer. So let's desolder the transformer. So after much endeavor, the switching transformer is finally out, and now let's make an autopsy. Let's remove the tape from the edge. Now it looks like we got some more tape covering the various core and stuff. A bit annoying. There you go. Okay, so it looks like we have a tiny strip of copper that's going around from one of the primary pins to this little copper tape, and I think that's for some sort of interference suppression. And if there's enough interference suppression in this transformer, then we don't even need a class-wide capacitor between primary and secondary side. And this is that blue capacitor that I was talking about before. It's a 1 nanofarad, 1 kilovolt capacitor, but it does not connect the primary and secondary sides. I think it's a snubber capacitor. But anyway, let's dig deeper into this transformer. I think this copper strip actually goes all the way around, so I'm just going to snip straight through it. And remove this wire too. Oh. Okay. So now I think there's yet another copper strip going around the actual core. So let's just remove this tape. Okay. That's the tape. And that is also a copper strip going around the core, because the core is, even though that's ferrite, it is still slightly conductive, so it radiates interference, and by connecting this to a stable, positive, high voltage without a high frequency signal on it, then that will just help eliminate some of the interference. Let's remove this tape, or whatever this is. It's probably a tape of some kind. Yeah, that will work. Doesn't have to be all the way removed, just cut along the edges. Now we can split apart the ferrite core using this one. Pop it open. That's the seam. Now it should split. Oh, okay. That works too. I guess we can just destroy the ferrite core instead of just separating it. And it still doesn't come out. This is going horribly. It's going great already. So, now that the transformer has been freed of its ferrite core, let's unwrap the tape holding this together. Okay, so here is our first winding. I think this is the feedback winding. One of its wires... Oh, no, it's not broken. So let's just see how many turns we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 turns of the feedback winding. Now let's just clip this off and see if we have any surprises hidden inside. Some weird tape. Normally you don't see this thick tape inside of a transformer. Even in good ones you don't typically see this thick tape. I'm not sure what's the deal with this thing. It's a very strange transformer. Okay. So now here's our second layer of normal transformer tape. And now we have a small interference shield, which was connected to one of the positive high voltage with no high frequency, and my stuff's getting covered in transformer tape and wires and bits and pieces of crap. Now, let's remove this other layer of tape to get to a different layer. Okay, so this looks like a insulated secondary. I was wrong when I said the secondary didn't look like it was insulated, because normally the secondary is extended out in good transformers, but this one I couldn't tell whether or not it was extended out. But this one does look like it's a relatively safe secondary, because it's got some insulation. It's not triple insulated, but it's better than nothing. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness. It's a bit annoying, but there you go. That's your secondary, and the pin fell off. Now all we have is the primary. Okay, it's definitely tough. Let's see what else is lurking under these tapes. Oh, this is annoying. Okay, so it's done. Looks like we have yet another interference shield, which I guess makes sense since the secondary is in a small sandwich underneath all the rest of the windings. My goodness, this is really not well. Didn't do exactly an amazing job of tearing apart this transformer. Now we have another layer of tape that looks almost like it's molten, but it's just the remains of the tape that was on before it. Now this last layer of tape, and then the primary should be right under this one. Okay, that looks like primary. Looks like one of its sleeves is insulated. That's interesting. I'm not sure, because there's another layer of insulating tape under this. Maybe it's, maybe there's another turn of primary. Let's rewind this off camera. 105, 106, 107, 108, 109, 110, 111, 112, 113, 14, 15, 16, 17, 118, 119, 120. So that's what appears to be just one section of the primary, and now it goes straight into another section of the primary, insulated with yet more insulating tape. This is a big primary. My goodness. Or is it? It just appears to be insulating tape that covers up the bottom of the bobbin. Is it? I think it is. Let's dig deeper. Actually, wait a minute, is that another interference shield of some kind? Oh yeah, there is a tiny interference shield under there, and then at the bottom there is the rest of the bottom. So, that's the transformer reverse engineered. So, the transformer, let's just draw the ferrite core, it has a primary of 120-ish turns, an auxiliary of 19 turns, or feedback, or whatever you want to call it, and then a secondary of, I think it was 11 turns for the secondary. And then let's not forget there were also some various interference shields and other measures for interference suppression inside the transformer. So, that's enough for the exploration of the switch mode power supply for some sort of portable speaker.